Hello guys, welcome back to the Python lecture series. Today we will be talking about the I guess we have completed till tuple, right? Yeah. So you can see the tuples are completed. Now we will be talking about the next data type, which is going to be set. But before moving in that direction, if you guys remember, I have given you one question to solve, right? So first we will talk about this one, and then later we will move on to the question. Next data type. Okay, so let me hop into the whiteboard and let me tell you that how we can reverse a tuple. So if you guys remember before, when we were talking about list and we thought of reversing a list. So for reversing a list, we were having the method that helps us to reverse the list, that is dot reverse method, right? Now I told you that methods are completely dedicated for that particular data type. Okay, now when we are saying that methods are dedicated for the particular data type, which means I cannot use this method for any other data type. Okay, so if I want to reverse a tuple, it is not possible that I can reverse a tuple with the help of this method, because it is not going to get supported here. Now, so how we can reverse a tuple? The question arises that I don't have any built-in function, I don't have any method, then what is the way possible of reversing a tuple? So the answer is we can reverse a tuple with the help of slicing. If you guys remember, what is slicing? Previously, indexing was saying that I can extract one element at a time, right? With the help of indexing. Wow, whereas in the slicing, it is allowed to extract more than one element at a time. Okay, indexing, let's say more than. Okay, indexing says that extracting one element at a time, whereas slicing says that extracting more than one element at a time. Okay, so if you guys remember, I have shown you the syntax of slicing. We always mention starting index position, we mention ending index position, and we also mention the jumping statement. So suppose, let me give you one example of tuple. Let's say this is your tuple, and in tuple we are having some elements, let's say 10, 20, 30, 40 and 50. Okay, so in this tuple, suppose if I want to extract these two elements, I can easily extract by writing simply the name of the tuple and the index position like this within the square bracket. Starting index position is going to be 1, ending index position is going to be 3. Okay, but now what about the jumping element? Jumping element says that whenever you want to extract the element while skipping the elements in between. Suppose I want to extract 10, I want to extract 30, I want to extract 50, which means I am skipping the elements in between, right? So how we can do that? This jumping element is going to get triggered. I can simply write the name of the tuple, the starting index position, which is nothing but 0. The ending index position, I know we are going till the end of the list, so I'm keeping the ending index position as blank, because by default Python understand that we have to go till the end of the list. Now the jumping element, how many jumps we are performing? The number of jumps are 2. Okay, so if you want explanation of that, let me give you the explanation how the number of jumps are 2. Let's say this is your first place, right? If I am going to make one jump, I will come at 20. If you are going to make second jump, we will land at 30. Okay, now the one jump is going to take me to the 40, second jump is going to take me to the 80 or 30 or 50, whatever it is written here. Okay, so one number of jump, second number of jump, that's why two number of jumps are written. That will help us to skip the element in between. Okay, now this is happening in the forward direction. This is not only the jumping statement, but it is also giving you the direction. Since it is positive, we all already understand that it is in the forward direction. Okay, suppose I will make this negative, so either of moving here in this direction from left to right and making jump in this direction, we can move in this direction and make a jump from right to left. Okay, so just by putting one minus, it is going to start taking the reverse jumps. Okay, let me erase the drawing and let me again show you the example. Suppose this is your tuple again, guys, and slicing is supported for both the data type, let's say list and tuple both. Okay, so we are having some sort of elements present in the tuple. Okay, now the elements are there. Let me mark down their index positions in the forward indexing manner, also in the backward indexing manner. Okay, now we are moving from left to right, called as forward indexing. We are moving right to left, called as backward indexing or backward slicing. Okay, now focus on the fact that we want to read these three elements. We know that it is going to happen with the help of slicing itself, but we want to read in such a direction that 21 is going to get printed first, 22 is going to get printed first, then 21 and then 11, which means we are going to read this in this direction. Okay, so how can we do that? We can simply take the help of slicing by writing the name of the tuple. Okay, now within the square bracket, what is going to be my index position? This is 4, so I am going to write -4 as my index position, putting one colon where we are ending at -6, but you guys know that we have to pick last but one always, so that Python understand that it has to come till here. Okay, so I am mentioning the ending index position as -7. Now since we have to move in this direction, my number of jumps are going to be 1, right? I am performing one number of jumps, but in the reverse direction. So -1 we are writing for the reversing of the elements. So instead of printing 11, 21 and 22, it is going to print 22 first, 21 second and 11 third. So just to reverse the direction, we have to perform the things in the reverse direction manner or backward indexing or slicing manner. And just to reverse the printing direction, we have to give minus in the jumping element. Okay, now let's take another example. Let me erase this one. Let's take another example and let's try to extract these three elements. Okay, but 24 should get printed first, 23 should be second and 22 would be third. So in that case, we can simply write the name of the tuple. Now look into the index position of the backward direction. It is -2. Okay, so I am writing -2 because we have to print 24 first. Okay, now putting one colon, the index position of the end element, which is -4. We have to always write but one index position, which is going to be -5. No problem. Now since we have to print the answer in this direction, which is usually the opposite direction, so for that opposite direction I am putting minus in the jumping element. And now you can see how many number of jumps we are performing. 1 jumps. So this is going to print these three elements out of the tuple. Okay, now let's come back to the point where we were talking about how we can reverse a tuple, right? So for reversing a tuple, what is reversing a tuple? We have to print every element in the reverse direction, right? Let me erase this one. So since we have to print every element in the reverse direction, let me write it down, reversing a tuple. which means we have to select the whole tuple and we have to just change the direction. So for selecting the whole tuple, can I simply write tuple within the square bracket colon? You guys know, if I'm not going to mention the starting index position, I'm also not going to mention the ending index position. By default, Python will understand that it has to select the whole tuple, right? So for the selection of whole tuple, you have to simply put one colon, right? We have covered this thing in the previous lecture. Now putting another colon just to mention the, let's say, jumping element. We are moving in this direction. So for moving in this direction, which is opposite to the usual direction, we are putting minus here. How many number of jumps we are performing with each element? 1. So colon minus 1 is the answer for reversing a tuple with the help of slicing or backward indexing. Okay, so simply excuse me, let's go back to the Jupyter notebook. Let's create a tuple and let's see how we can perform the reversing of a tuple. So this is, let's say, tuple underscore reverse. I'm declaring one tuple, let's say 10, 20, 34, 56, 89, 34, whatever it is. Okay, I'm just declaring tuple of random elements. Now I want to reverse this tuple. What I told you, for selecting this whole tuple, we have to simply write the name of the tuple within the square bracket, putting one colon. If I'm not going to mention the starting index position or ending index position, by default Python is going to understand that this colon is signifying to select the whole tuple. Once you're done selecting the whole tuple, then now you have to mention the direction, right? Because we have to print this in the reverse manner. So the direction is reverse, which means the minus 1. Now we have to make one jump. That's why we are writing. So colon minus 1 is the answer that will help you to reverse the tuple. Running it, you can see it is reversing the tuple. 10, 20, 34, whatever the number of elements were there, everything is getting printed in the reverse direction. Now always understand that the changes which we are making, it is not getting stored or updated or manipulated in the tuple, right? If you check your tuple, you can see it is looking like the original one. So you can store this in some variable x and you can print or use the variable x every time you want to see the reversed tuple. Okay, previously in the case of list, when we were using dot reverse in the case of list, everything was getting manipulated, right? Let's say, let me show you what I'm talking about. This is your list, and you guys know that we have a method inside a list to reverse the list, right? What is the method? Dot reverse. So dot reverse is going to reverse the list. Now let me tell you one thing, that it is going to make changes inside your list, which means the changes are permanent in nature. Okay, so if I'm going to run this and if I'm going to print list underscore 1, you will see the original list will not come up. The reverse list is going to come up. We are reversing the tuple with the help of slicing. That's why we have to store this in some variable and later we can use this variable. But right now here we are reversing a list with the help of reverse method. So the methods, whatever methods are making the changes inside the list, they are permanent in nature. They modify the list, they completely change the nature of the list. That's why we say that methods are only dedicated for the particular data type. We have some methods which are supported for the tuple, we have some methods which are supported for the list, and we cannot use each other's method into each other data type. What all there inside the tuple, we can use that for tuple. What all are there inside for list, we can use that for list only. Okay, so it is very specific, don't forget that. Now here your tuple section gets over. Now we are done with two data type. The first one was your list and the second one was a tuple. Okay, now we will talk about third non-primitive data type, which is your set. Okay, now what are sets and how we can declare sets? Okay, let me give you the heading. Sets. Okay, now sets are the data type which we have to understand first. Okay, it is completely different from rest of the data types, non-primitive, which we have covered till now. So let me clear the drawing. Let me give you the heading. Changing the color of the pen. Let's pick this one. No, it's very boring. This one. Let me give you the heading, sets. Okay, now sets are not normal, or let's say the data types we have covered till now, sets are not same as of those data types. Okay, when I'm talking about set, we have to first understand the characteristic of sets. Okay, we are having different characteristics, completely different as compared to the data types which are non-primitive in nature we have covered till now. Sets are completely different from that of your list and tuple. Okay, so first we are going to understand the characteristic of set. Point number 1, how we declare set. You guys know we declare list with square bracket, we declare tuple with parenthesis, we declare set with the help of curly brackets. Okay, so first characteristic is that we declare set with the help of curly brackets. Okay, now the second characteristic is that set elements, right, they are very unique in nature. Set elements are unique. When I'm saying unique, what do we understand from that? Let's go back into the Jupyter notebook and try to understand. Suppose I'm declaring one set. This is set underscore 1 equals to. This is your curly bracket. I am mentioning the values like this. Some of the repetitive values are also there. Okay. Now, if I try to print this set, you will see one thing. Point number 1. Whenever I try to declare list and try to print that list, the order of declaration of elements inside the list is completely same as that of order of getting the output. I have declared 1 in the first place, I am getting 1 as the output in the first place. I declared 2 in the second place, I am getting 2 is the output in the second place. Likewise. So it is ordered in nature. The order of declaration is matching with the order of let's say printing or getting the output. But here in the case of set, you will see first I have declared 10, 20, 30, whatever order is there for the declaration of element, it is not matching with the order of getting or receiving the output. So sets are unordered in nature. The order of declaration does not match with the order of receiving the output. So first I will explain you this, why we say set elements are unique, but let me write down the third characteristic, which is sets are unordered in nature. When I'm saying unordered, which means the order of declaration of set is completely different from receiving the output. Okay, you will see completely different order in the output and you will see completely different order while declaring the set. Okay, that's why we say it is unordered. Now let's go back to the second characteristic. What it says, that set elements are unique in nature. What do we understand from unique? Unique means something which is not duplicate, right? Something which is appearing only one time. So if you go back, you will see I deliberately duplicated the elements. Let's say 10 is coming 2 times, 20 is coming 2 times. Okay. So if you see, I deliberately duplicated the elements here while declaring the set. But if you see the output, 10, 20, they all are coming only one time. Okay, so that's why we say whenever we declare set and when we try to print the set, duplicate elements are getting ignored. That's why we say sets carry unique elements or set elements are unique in nature. So two main properties, that sets are unordered. The order of declaration does not match with the order of receiving the output. We don't have any scientific reason how the set elements are getting printed. It is completely random. Okay. Also, if you see the order of declaration in list, same while receiving the output. This is going to happen same with the tuple as well. The order of declaration, same you will receive in the tuple also. Okay. But in the set, you will see it is completely going to be unordered in nature. Okay. Now, three things are covered. The fourth characteristic is set does not follow indexing. When I say does not follow indexing, what do we mean by indexing? Whenever we declare element, you will see on the top that there are different indexes available. Okay, so for that, you are going to pick this up and let me show you in the visual tutor how this is looking like. Okay, first I will declare one list or tuple which follows indexing, and then we will declare set to see what actual difference it is creating. Okay, let's visualize the execution. This is your tuple. You can see clearly the indexes are visible. In this set, you can see, are we getting this similar visualization of tuple to that of the set? No. Can you see some sort of indexes in the set? No. That's why we say if we do not have indexes, how we are going to decide the order of printing elements? We cannot, right? So sets are unordered, unindexed and carry unique type of elements. Okay, this is the proof of that. Okay, coming back to the point, these are the characteristics of the set. Also, how to declare empty set. How we can declare empty set. So for the declaration of empty set, let me tell you how we can declare empty list. This is your empty list. Very easy. You can see if you want to check the data type of this, you can simply write type built-in function and check the data type of empty list. You can see it is showing list. Similarly, you want to do the same with tuple. You can write tuple, empty tuple, and you want to check the data type of empty tuple. It is going to be tuple itself, no difference. You can see. Now, but the third thing, whenever you try to declare empty set and you want to check the data type of the empty set, you can see what it is showing, dictionary. Dictionary is the data type which we are going to cover after set. But why it is showing dictionary as the answer as of now? What is the reason why empty set is showing the dictionary as answer? So for that purpose, let me tell you one thing. Whenever you want to declare the empty set, you can declare with the help of built-in function called as set. Okay, declare this set built-in function like this. Mention the type of set underscore 2. Then you will see it is showing set. So we have two conclusions out of this statement. What are those two conclusions? That we don't have any concept called as empty set which we can declare with the help of curly brackets. Whenever you want to declare empty set, you have to use this particular funda. Now the another thing, that why it is showing dictionary. It could show some other data type as well. So once we jump into the dictionary, you will see dictionary also gets created with the help of curly brackets. Okay, so why this is why dictionary, it is showing dictionary here as the output. Okay, now we have also learned how to declare the empty set. We have also understood the characteristics of the set. Now let's talk about, if you guys remember, there is one more factor which we always talk about related to the data type. Let's say once we covered the list, you guys got the idea about the mutability and immutability, right? We understood that sets are mutable in nature, which means once we declare the set, after declaration, I can add up the elements, I can remove the elements from the list, and I can replace the elements of the list. Similarly, tuples are immutable. After declaration of the tuple, I cannot add element, I cannot remove element, neither I can replace the element. What about set? Are they mutable in nature? What about set elements? Are they immutable in nature? What is the case here? So we'll try to understand the mutability factor of set. Okay, so for that purpose, let me tell you set underscore 1 and some sort of elements I'm declaring in the set. Let's say some string type of values also I'm declaring. So as of now guys, we are sticking to only the string, or let's say only the primitive type of data to declare inside the set. Okay, later we will see what all data types are supported inside the set. Okay, but first let's understand the mutability factor. So set underscore 1 is my set. I want to add some elements in this set, so I'm writing set underscore 1 dot add. What I want to add 50. Running this, if you check set underscore 1, you will see 50 present in your set. Okay, now let me write it down, adding the element. Okay, suppose if I want to remove the elements from the set, so we have set underscore 1 dot remove. We can clearly remove the elements from the set as well. Okay, so for that I am mentioning I want to remove 60. Running it, if you check your set underscore 1, you will see we don't have 60 present inside the set. Okay, chalo, we understood how to add elements, how to remove elements. Now what is the next thing? Can we replace the elements? Guys, these are two very different things. Okay, whenever we talk about mutability factor, let's say for the list, for the tuple, and for the set, what all data type we have covered till now, mutability factor comes in two format, in the element format and in the data type itself format. Okay, now we have to understand that mutability of the element is completely different from that of the mutability of data type itself. Okay, if I am capable of replacing the elements present inside the list, then I say that list elements are mutable in nature. Let me repeat that again. If I am capable to replace the elements present inside the list, let's say you are having X list, we are having some sort of elements here. I want to make this 10 as 100. Can we do that? Yes, of course. You can do that with the help of indexing. X of 0 equals to 100. Excuse me. If you run this code and check X list again, you will see it is getting replaced. Now we are having the new value, which is 100. Right? So in that purpose, we can say that list elements are mutable in nature. No problem. List itself, if I want to add some element inside the list, yes, it is possible with the help of append method, extend method. If I want to remove some element from the list, yes, it is possible with the remove method, pop method. So list itself is also mutable, which means editable. It is allowing me to change itself, change the size of the list, shrink or extend. Okay, tuple element, if I want to replace the tuple element, is it possible? No. So that makes your tuple immutable in nature. We don't have any procedure for replacing the element present inside the tuple. But let's say if I want to change the tuple itself, is it also possible? No, we don't have any other data type. So it is again going to come under the category of immutable. Okay, now set data set itself. Okay, you can see previously set was like this. I am adding the element into the set, I am removing the elements from the set, right? Which means I am enhancing or extending the size of set, and I am also reducing the size of set. Okay, so in that case I can say that sets are mutable. But let's say if I want to replace this 50 to 500, is it possible? No, we don't have any method. Even if we try to perform this with the help of indexing, not going to work, because we don't have the concept of indexing present inside the set. So set elements are immutable in nature. Okay, now when set elements are immutable in nature, we have to be pretty much sure what all data types I can declare as element inside the set, right? I cannot just randomly declare whatever data type I want to. I have to follow the mutability factors of different data types, and then only I can declare. So let me tell you, in set only few data types are supported. What data type? You can declare all the primitive data types. Okay, you can declare all the primitive data types along with the tuple. Why tuple? Because if you look into the mutability factor of tuple and set, they are matching. Okay, the element and the data itself is immutable, so I can declare this thing here as the element. Okay, so only all primitive data types, let's say integer, float, bool, and string, these all are supported along with the tuple only. You cannot even declare set inside set, which means we don't have a concept of nested set. Okay, we have concept of nested tuple, we have concept of nested list, but we don't have concept of nested set. So this is all about your set. If somebody asks you the question, you have to give them answer in this particular manner. Okay, you can also see the mutability and immutability table. I am expecting you guys to jot it down somewhere. Okay, because it is very important. Okay, and useful as well. You will find this very useful in the near future. Okay, chalo, let's move forward. Let's do some practical things on set. Now since I am declaring the set, okay, since I am declaring the set, I have to be pretty much sure since we are talking about the set, we have to be pretty much sure, okay, that what all operations I can perform. If you want, you can simply write the help section of the set and run it. Okay, so you will see it is going to give you the definition of set as well. What it is showing: build an unordered collection of unique elements. This is the same definition which we have written here. Can we say that? Yes, all the things which we have written here is same as that of the definition written here in the help section. Okay, so and also see one thing, whenever you want to declare some new empty set, you have to take the help of this. Okay, that's what we have discussed above, that we cannot declare empty set like this. It is going to be considered as dictionary, right? So that's why we are declaring this, let's say, with the help of built-in function called as set. Okay, now coming back, there are so many methods present inside the set. So we are not going to cover every methods, but we are going to cover some of the methods which are very important. Okay, so let's talk about merging of the data type. Let me write it down. How to merge different data types. So for merging of different data type, let's say we are having one list which we have already declared, I guess. Let me pick it from above. You can see we are having list 1. Pasting it down, you can see this is your list 1. I am declaring one more list which is list 2. Okay, now suppose I want to merge these two lists. Merge means I want to add these two lists to make one. I want to perform merging so that they become one. Right now they are two individual lists. I want to make them as a single individual list. Okay, so for that, okay, sorry for that. So if I want to add up these two, adding means what? I don't want summing these two lists up. No, I want a merging of these two lists. So I can simply write list underscore 1 plus list underscore 2. So you can see it is merging those two lists like this. Previously you were having list 1 like this and we are having list 2 like this. I want to merge them and make it a single one. So you can see now it is looking like a single list. Similarly, if you want to merge two tuple, you can see we are having tuple 1. Okay, let me declare one tuple 10, whatever numbers I am giving. Now I am giving tuple 2. I want to merge these two tuples. So I can simply write tuple underscore 1 plus tuple underscore 2 and run it. Now you can see what it is doing. It is just merging them up. Okay, so merging of a list, merging of a tuple. How we are going to merge the set? We have already declared one set like this. Now I am declaring the another set so that we can perform merging. So set underscore 1 plus set underscore 2. That is the basic thing which we guys were using. You can see it is showing unsupported operand. Now how we can perform merging? Because it is not supporting plus, right? So in that case, when we are stuck, we are going to take the help of the method present inside the set called as dot union. Okay, I'm going to simply write set underscore 1 dot union. Inside that I'm placing set underscore 2. Now you can see it is performing the merging of two set and making it a single one. So there is no restriction. If you guys want to merge 3 or more or 5, whatever multiple sets all together, you can write it down and declare like this. Okay, and write set underscore 1 dot union. Previously in dot union you were declaring only a single set. Now you can declare multiple set 2, set 3. Okay, run this. You will see it is merging up two sets. Always understand that it is merging two sets, but it is also keeping the identity of the set intact, which means set follows the characteristic of not printing the duplicate elements. So if I am having the duplicate elements among 2 or 3 sets, it is going to eliminate those duplicates element. Okay, so this is how it works. Okay, the union of two sets. Now suppose you are having two sets and you want to find the common element between them. Let me write it down. How to find common elements between the sets. Okay, so this is your set underscore 1 looking like this. set underscore 2 looking like this. You can see we are having 30 common between two sets. We have a method called as intersection. So set1 dot intersection set2, you will see it is going, okay, we have two elements in common. In set 1 30 102, in set 2 30 102. So we are having two elements in common, and it is let's say giving me the answer of two common elements out of the set. Okay, so this is the union, this is the difference, and it is all about your set. Let's say sets are very rarely getting used data type. Okay, we hardly use sets somewhere, because we are having very good data types called as list and tuple, which gives us the wide variety of adding up the element, and it is very flexible as well. If I want to perform indexing, slicing, those all are supported in list and tuple, but that is not the case with the set. Okay, so sets are very rarely getting used. That's why we are not digging deep into the set, we are just touching the set. Okay, so let me walk you through what all we have covered. First, we started with the set characteristics. Set we declare always inside the curly brackets. Now set elements are always going to be unique, which means we cannot print duplicate elements. Sets are unordered in nature, which means order of declaration of set is not going to match the order of the output of the set. It does not follow indexing, which also means that it is also not going to follow slicing. Okay, I forgot to mention that point. Always keep this in mind. The data type which follow indexing, that is going to be the similar data type which follow slicing. Okay, so only those data type follow slicing which follow indexing. Okay. Okay, so it does not follow indexing or slicing. How to declare the empty set? I have shown you that we have the logic of declaring empty set with the help of built-in function. So whenever you want to declare the empty set, you are going to take the help of this built-in function. Now what is the concept? That we cannot declare empty set even if we cannot declare nested set. Even if we want to declare, we cannot. Now if you look into the data type, what all data types are supported, we have a listing of this. Why these all data types are supported? Because of this table. This table is telling me the mutability and immutability factors of the different data type, and based on that it is giving me the answer that what all data types I can declare inside the set. Also, we have declared the set, we have gone